Hello there, and welcome to Just About Earth, where curiosity takes a slow breath and science wanders gently through questions that feel both strange and strangely familiar. Tonight, we'll drift into an idea that sounds almost like something out of a story, but rests on the edge of science, geology, and imagination. What if the world you know, this Earth beneath your feet, isn't the first version of itself? Not in the sense of dinosaurs or trilobites or mammoths, but in the sense of something more like us. Minds that wondered, hands that built, civilizations that perhaps rose and fell so long ago that even the rocks themselves struggle to remember. Before we let that thought unfurl, I'd like to ask you something simple. Where are you listening from tonight? What does the room around you feel like? Maybe it's quiet and dark, maybe it's a little noisy, maybe you're curled up with your phone or drifting in the soft glow of a laptop. Wherever you are, this is the moment we share together, one among millions of moments this planet has seen. And if you enjoy finding calm in questions that don't always have answers, I'd be grateful if you gave the video a like or even subscribed, because this little space of science and rest only grows when more people find it. Now, let's settle in. Because to imagine that Earth has hosted versions of itself before us is not just to look backwards, but to reconsider what it means to exist right now. The first thought people usually have when this question comes up is dinosaurs. They ruled for over 150 million years, longer than humans have existed by a factor so large it makes our own timeline look like a post-it note stuck on the side of a novel. But dinosaurs, as fascinating as they are, were not engineers. They didn't leave behind machines or cities or written languages. Their legacy is bones, footprints, and sometimes the delicate imprint of feathers pressed into stone. So when we ask whether Earth has hosted civilizations before us, we're really wondering about something entirely different, something that would leave behind artifacts of thought, not just of biology. It's an odd question because the evidence for us is everywhere. Plastic in the oceans, glass in the sand, steel buried in foundations, satellites orbiting overhead. If another species were to rise millions of years from now, they would almost certainly know we were here. Unless, of course, enough time passed for the Earth itself to do what it always does: recycle, erase, fold, and renew. Geology is not kind to memory. Sediments compress. Tectonic plates swallow continents. Oceans open and close. The very crust beneath our feet is not permanent, but a restless surface that hides as much as it reveals. That's what makes the question worth exploring. Could another civilization have existed so far back in time that the Earth has already forgotten it? This idea has a name in scientific circles, though it's usually posed half seriously. It's sometimes called the Silurian Hypothesis, after a race of fictional reptilian people in British science fiction. A couple of actual scientists, Gavin Schmidt and Adam Frank, raised it not because they believed in ancient reptile civilizations, but because the thought experiment itself is valuable. If we wanted to find evidence of an industrial civilization that existed millions of years before us, what would we look for? What would survive? And just as importantly, what would not? The reality is that solid objects rarely last. Even something as massive as a skyscraper would be reduced to dust over geological time. The Empire State Building, left untended for tens of millions of years, would not stand proud. It would collapse, weather, rust, and eventually become indistinguishable from the sediments it sank into. Fossils of bones survive only under very specific conditions, and fossils of wood, fabric, or plastics are even more unlikely. But there are other kinds of traces. Chemical signatures in the atmosphere, layers in sediments that reveal unusual spikes of carbon, metals, or artificial isotopes. In fact, if you look at Earth's geological record, there are moments where these odd signatures do appear, though they usually have natural explanations like massive volcanic eruptions or asteroid impacts. But the possibility remains that such markers could also be the faint footprints of something else. When we look back, we don't see an unbroken history of Earth, but a patchwork quilt of fragments. Whole ages are missing, erased by erosion or tectonics. What we do know is that the Earth has been habitable for billions of years, and that complex life has existed for hundreds of millions. Within that span, there's plenty of room for rises and collapses we might never be able to detect. Even a civilization lasting for 100,000 years, which would be unimaginably long by human standards, would still be a blink compared to the deep time of geology. Once erased, it might be gone completely, leaving only the faintest trace, if any. And this is where the question becomes more than just playful curiosity. Because by asking whether there might have been civilizations before us, we also ask what traces we ourselves will leave. Will our plastics, our concrete, our isotopes mark a clear boundary layer for future geologists to find? Or will the churn of continents bury us so deeply that millions of years from now we too become a forgotten version of Earth? It's not about ghosts of the past so much as the fragility of the present. If Earth has hosted others before us, then we are just one more chapter in a very long book. And even if it hasn't, then we may be the only attempt so far, which makes our place in history both more special and more precarious. The thought doesn't have to be frightening, it can be grounding. Imagine the sheer span of time behind us, stretching into billions of years, and then realise that we're alive right now, in this particular blink. The air you breathe has circled this planet countless times. The atoms in your body have been recycled through stars, oceans, and living things long before you were born. To wonder whether there were others like us before is just another way of marvelling at how strange it is to be here at all. And with that, we can begin to follow the traces the Earth does keep. The rocks, the sediments, the cycles of creation and destruction that make up the story of this planet. Because if the Earth has hosted more than one version of itself, the only way we can know is by listening closely to what it still remembers. When you look at the ground beneath you, maybe a carpet, a floorboard, or a stretch of pavement outside your door, it's easy to forget that under all of it lies not just dirt and stone, but an archive. The Earth is a keeper of records, though not a very organised one. It buries, it shuffles, it erases, and sometimes it preserves. And every time we step outside, we're standing on a surface that has been many other surfaces before, each one part of a story that reaches back further than we can comfortably imagine. Geologists sometimes call the planet's crust a palimpsest. That's an old word for a piece of parchment that monks would scrape clean and reuse, writing new words over faint traces of the old. Earth does something similar. It lays down layers of sediments, lifts them up, erodes them away, and lays down new ones again. Each cycle adds a faint echo of what came before. Fossils, minerals, isotopes, trapped gases, even magnetic alignments that tell us which way the poles were pointing when that rock cooled. These are the whispers of the past, scattered and incomplete, but still there for anyone who knows how to listen. But here's the problem. The deeper you go, the less likely it is that those echoes remain intact. Rocks don't just sit still for millions of years. They melt, fold, grind, and slip under one another. Ocean floors dive into the mantle and resurface as mountains. The process we call plate tectonics is a kind of recycling program on a planetary scale. On average, the crust of the ocean floor is only about 200 million years old. To us that sounds ancient, but compared to the 4.5 billion years of Earth's history, it's just the latest chapter. That means if an industrial civilization had thrived 500 million years ago, much of the physical evidence would already have been swallowed into the depths and transformed into something unrecognizable. Still, not everything disappears. Fossils can last for astonishing spans of time under the right conditions. The trilobites that scuttled along seafloors over 500 million years ago still leave us their stony outlines. Entire forests have petrified into stone. Dinosaur bones, fragile in life, have become monuments of mineralization. Even delicate impressions like the feather of an Archaeopteryx or the ripple of an ancient tide can be preserved if the sediments were calm and the chemistry just right. That suggests that if there had been beings who built tools or machines, some trace might linger, not the machines themselves perhaps, but signs that something odd was happening in the environment around them. For example, consider carbon. We're leaving a sharp spike of carbon in the atmosphere and oceans, much of it tied to burning fossil fuels. It's likely that future geologists millions of years from now will be able to detect this as a distinct layer, a chemical fingerprint of our existence. If another civilization had burned fuels or reshaped their atmosphere, they too might have left behind such signatures. Similarly, we're producing artificial isotopes, radioactive elements from nuclear testing and reactors, that simply don't occur naturally in large amounts. If anything like that ever existed in the deep past, we might catch faint hints of it in the rocks. But here's where it gets tricky. Earth has had plenty of natural spikes and anomalies. Volcanic eruptions can flood the air with carbon and sulfur. Meteor impacts can scatter iridium across the globe. Rapid warming and cooling events have happened long before humans existed. The Permian extinction, about 252 million years ago, saw carbon levels soar and temperatures rise catastrophically. The reasons are still debated, but massive volcanic eruptions are the leading suspect. To us, that might look similar to the industrial footprint we're leaving now. If geologists in the future find a layer rich with anomalies, how will they decide whether it was nature or industry? Could some of the strange events in Earth's history already be the echoes of something more than geology? This is where the Silurian Hypothesis becomes both fascinating and humbling. The scientists who proposed it weren't suggesting we have solid evidence of ancient civilizations. They were saying that our ability to find such evidence is limited, and that raises uncomfortable questions. If we disappeared tomorrow, how much of us would remain in 10 million years? 100 million? 500 million? Would anyone know we'd been here? Think of a modern city. Glass towers, asphalt roads, metal bridges. In a few centuries without maintenance, nature would reclaim them. Plants would split the pavement. Steel would rust into flakes. Concrete would crumble. Give it a few thousand years, and most of it would be buried under soil, rivers, or shifting sands. A few relics might survive in caves or deserts, but on a global scale the fingerprints would fade fast. In 10 million years, tectonics would have warped the land beyond recognition. Unless some traces made their way into stable sediments, it might be as if the city had never existed. Now extend that thought across millions of years more. How many versions of Earth might have risen and vanished, without a whisper loud enough to reach us? The rocks we study are filled with noise, and sorting the human-made from the natural is not straightforward. A sudden spike in temperature, a strange mix of elements, or even a mass extinction could look like the aftermath of industry. Or it could be the result of an asteroid strike. We tend to favour natural explanations because they require fewer assumptions. But the fact that we can even raise the possibility shows how faint the line is between what is natural and what is manufactured when you zoom out far enough in time. It makes you wonder about what counts as evidence. If an ancient civilization used biodegradable materials, little would remain. Even if they built with metals, most of those would corrode away. What if they lived in harmony with nature, altering ecosystems but leaving no skyscrapers behind? Would we even recognise their presence? Maybe what survives is not their cities, but subtle changes in sediment, odd mineral deposits, or unexplained isotopic ratios. In other words, maybe the echoes beneath our feet are already speaking, but we don't know the language. There's another challenge. Humans are biased towards seeing patterns. We want to find meaning, to connect dots, even when the connections are weak. That means we have to be careful not to see civilization where there is only geology. But the opposite bias also exists. Assuming that civilization is impossible in deep time simply because it seems too far-fetched. Balancing those two biases is hard. It requires curiosity paired with caution, imagination tempered with evidence. Still, even raising the question forces us to look at the ground differently. Walk across a rocky beach, and you might see pebbles, shells, seaweed. But to a geologist, Those rocks are pages of a book, each with its own record of an environment, a climate, even a catastrophe. To wonder whether some of those pages hide the faint marks of another intelligence is to expand the story of Earth beyond just us. Maybe the echoes are faint because the planet itself insists on renewal, or maybe they're faint because they were never there at all, and we are truly the first. Either way, the ground beneath our feet is never silent. It hums with memory, even if most of it is too quiet for us to hear. And as we listen for those echoes, we also hear ourselves, our footprints, our emissions, our structures, all layering into the record that future beings might study. The question of whether we are alone in Earth's history reflects back into the present. How loud do we want our echo to be, and how long do we want it to last? If Earth could speak, what would it say about everything it has seen? That question lingers when you look at a cliff face with its layers stacked like pages of a library. Some pages are thin, barely a whisper of sand or silt pressed into stone, while others are thick, coloured by iron, ash or ancient seas. Taken together, they form a memory far older than any human record. This is the planet that remembers, though it remembers in its own way, not like we do with stories and pictures, but with stone, minerals and chemical traces. Think about how fragile our own memories are. We forget names, we blur events. Sometimes we even remember things that didn't happen quite the way we think they did. Earth is no different. Its memory is imperfect. It records selectively. Some moments are preserved with striking clarity, like a fish caught mid-swim in the layers of shale, or a palm frond flattened so precisely you can count its veins. Other moments, entire ages are wiped clean, leaving only gaps. Yet even in its forgetfulness, Earth carries more than we often realise. For geologists, reading these memories is an act of patience. Every rock has a story, but not every story is easy to translate. Sandstone might speak of ancient rivers, limestone of shallow seas, coal of swampy forests compressed under pressure. Volcanic ash layers tell of eruptions that darken the skies. When you find a sudden boundary where one type of rock sharply changes to another, it can mean something dramatic happened. A flood, a climate shift, a mass extinction. In that sense, the planet remembers the same way scars remember an injury. The details may fade, but the mark remains. What's most fascinating is that Earth doesn't just remember biology, it remembers physics and chemistry. Inside its minerals are records of ancient atmospheres, tiny bubbles of air trapped for millions of years. Ice cores hold a timeline of temperatures, carbon dioxide levels, even volcanic eruptions written in layers of snow and dust. Magnetic minerals in lava align themselves with the Earth's magnetic field as they cool, freezing in place, a snapshot of which way north was at the time. Put all these pieces together and you begin to see Earth not just as a stage for life, but as a recorder of everything that's ever happened here. Now, the tricky part is that this memory isn't eternal. It fades, it erases, it overlaps. Imagine trying to reconstruct your childhood by finding scraps of old homework, broken toys, and photographs with corners missing. That's what science is doing with Earth's past. And in between those scraps are long stretches where we have no record at all. That's why the idea of earlier civilizations is both so compelling and so difficult. If they existed, would the planet's memory hold enough to tell us? Or would those traces be lost in the noise? Some of the clearest memories Earth has are the catastrophic ones. The asteroid impact that ended the reign of the dinosaurs, for example, left a worldwide layer rich in iridium, an element rare on Earth's surface but common in space rocks. That layer is like a bookmark in the story, instantly recognisable wherever it appears. Similarly, massive volcanic events leave behind thick deposits of basalt and chemical fingerprints that scream of fire and smoke. These stand out because they are global and abrupt. If a civilization caused planetary scale changes, we might expect to see something like that. A sudden spike in carbon, a thin layer of unusual materials, an anomaly in the chemistry of sediments. But here's a thought worth sitting with. We tend to think of civilizations in terms of grand monuments and machines, yet Earth doesn't remember in those terms. It doesn't care about buildings or languages. It remembers chemistry, pressure, temperature, magnetic fields. That means if we're looking for echoes of ancient intelligence, we shouldn't just look for artifacts. We should look for disturbances in the patterns Earth usually keeps. Something that doesn't fit the normal rhythm of volcanoes, meteors, or climate cycles. A strange scar in the geologic record that could suggest more than geology alone. Of course, the challenge is that nature is messy. It doesn't produce neat graphs or timelines. It leaves ambiguous signals. A sudden warming could be a greenhouse gas spike from industry, or it could be the natural outpouring of lava from deep within the crust. A thin layer of odd metals could be the residue of a mining culture, or it could be dust from a meteorite burning in the atmosphere. The planet remembers, but it doesn't annotate. There are no labels in the rock saying, "This was us." That ambiguity forces us to think about our own memory as a species. We build archives, libraries, digital storage. But how long will those last? Stone carvings can endure for thousands of years. Paper can last centuries if cared for. But hard drives, servers, and cloud data, those are fragile. If society were to vanish, our digital memory would fade shockingly fast. Within a century, most of it would be gone. Within 1,000 years, only fragments would remain. Within 1,000,000, almost nothing. Earth might remember us, but not in the way we hope. Not with our stories intact, but with traces of our impact embedded in stone. It raises a strange possibility. If there were civilizations before us, maybe they too had stories, histories, archives. Maybe they wrote books, etched symbols, stored data. But the planet doesn't preserve those kinds of memories very well. If anything remains, it would be subtle. A chemical anomaly, an odd mineral deposit, a thin scar in the record. In that sense, Earth's memory is more like a dream than a diary, vivid in some places, blurry in others, often frustratingly incomplete. And yet, for all its gaps, Earth remembers enough to give us perspective. It remembers 5 mass extinctions, each one reshaping life in ways almost unimaginable. It remembers climates far hotter and colder than today, seas that rose and fell, continents that collided and drifted apart. It remembers forests turning into coal, shells turning into limestone, mountains rising and wearing away, and through all of it, life has found a way to adapt, to continue, to return. That might be the most important lesson hidden in the planet's memory. Even if civilizations rise and fall, even if entire species vanish, the story goes on. Earth doesn't cling to one version of itself. It changes, renews, erases, and begins again. To wonder if others came before us is also to realize how temporary we might be, how easily our part of the story could become just another faded layer. But that doesn't make it meaningless. If anything, it makes the present more precious, because we are alive in one of the rare moments Earth has chosen to remember in such detail. And as we press our ears to the ground, so to speak, listening for those echoes, we also remind ourselves that we're shaping the memory Earth will keep of us. Whether it will be a scar, a whisper, or a clear and lasting mark is not yet decided. But the ground beneath us is already writing it down, layer by layer, grain by grain, patiently storing away the record of our age. If you stand in a museum and look at a fossil, maybe a towering dinosaur skeleton, or the delicate impression of a fern, it's easy to forget that the creature or the plant you're looking at once lived in a thriving world of its own. A world with its own climate, its own struggles, its own rhythms of life and death. That world is gone, erased by time, but its traces remind us of a simple truth. Earth does not move in straight lines. It moves in cycles. Periods of flourishing are followed by collapses. Creation and ruin take turns writing the script of history. We humans often think of history as progress, as a steady climb from caves to cities, from stone tools to satellites. But Earth's memory tells a different story. It tells us that nothing is steady for long. Whole ecosystems rise and fall. Entire families of animals dominate for millions of years and then vanish almost overnight. Each time, the loss feels total, yet life eventually returns, reshaped into something new. These cycles are not rare accidents. They are the rhythm of the planet. One of the clearest examples is the series of mass extinctions that punctuate Earth's history. There have been 5 major ones, and many smaller ones along the way. The Ordovician extinction wiped out most marine life around 443 million years ago, likely triggered by a sudden ice age followed by warming. The Devonian extinction came next, erasing many early fish and reef builders. The Permian extinction, sometimes called the Great Dying, was the worst of all, around 252 million years ago. Over 90% of species disappeared. Imagine almost everything alive today gone in a geological instant. Then came the Triassic extinction, clearing space for dinosaurs to take over. And finally the famous Cretaceous extinction 66 million years ago, when an asteroid ended the dinosaurs' long reign and opened the door for mammals to spread. Each of these events was catastrophic. Each marked the end of a world. And yet, in the ruins, creation followed. New species emerged, new ecosystems formed, new possibilities unfolded. That's the pattern. Destruction clears the stage, and life finds new scripts to perform. It's a harsh cycle, but also a creative one. Without the asteroid, there might be no humans. Without the Great Dying, the ancestors of dinosaurs might never have thrived. Without earlier extinctions, fish, plants, and mammals would not have spread the way they did. When you think about the possibility of civilizations before us, these cycles take on a different kind of weight. If intelligence arose once, might it have risen before, in some form we no longer see? And if it did, would ruin have swept it away just as easily as it swept away trilobites or dinosaurs? The cycle doesn't seem to care what it destroys. It is as merciless to intelligence as it is to coral reefs or ferns. If earlier civilizations existed, they too would have been at the mercy of these forces. Asteroids, volcanoes, shifting climates, diseases, or their own mistakes. The cycle of creation and ruin doesn't only happen on grand scales. It happens in smaller ways too. Coral reefs grow, flourish, and collapse, sometimes over centuries, sometimes over millennia. Forests rise after glaciers retreat, only to be replaced by grasslands when the climate shifts. Rivers carve valleys, then change course and leave them dry. Even mountains, which seem eternal to us, are part of the cycle. They rise through tectonic pressure, only to be worn down grain by grain until they are plains once more. Nothing is spared. Nothing stands outside the rhythm. It's humbling to realise that even our own age, with all its technology, is just another point in that cycle. We are creating, yes, but we're also vulnerable to ruin. Climate change, resource use, nuclear risks, even cosmic accidents. All of these remind us that cycles continue whether we're ready or not. Our memory of history is too short to see how inevitable these shifts are. We imagine that cities will last forever, that nations and technologies will keep building upward. But Earth's story says otherwise. Every rise is temporary. Every flourish carries the seed of collapse. Yet the beauty of cycles is that they do not end with collapse. Out of ruin, there is renewal. The Permian extinction wiped the slate nearly clean, but from that devastation, the lineages that would become dinosaurs and mammals emerged. After the asteroid, mammals that had lived in the shadows of reptiles took the stage. Even the loss of ice sheets and the rise of deserts create opportunities for new life to adapt and expand. The end of one story is the beginning of another, though the characters change and the settings are unrecognisable. This brings us back to the question of versions of Earth. If the planet remembers cycles of creation and ruin so clearly in its rocks and fossils, then it's not impossible to imagine that intelligence could be part of those cycles too. Perhaps we are the first. Perhaps we are not. Either way, if civilizations rise in cycles, they would be bound by the same rules. They would flourish, leave their marks, and then vanish into the layers. The only difference is whether we, standing here now, can still hear their echoes. The cycles also remind us of scale. Our lifetimes are so short that we rarely feel the rhythm. A few decades, maybe a century, is all most of a sea. Even the span of human civilization, from early farming to the present, is only about 10,000 years, barely a tick on the clock of geological time. In that sense, we live in the stillness between beats, unaware of how loud the rhythm can be when it strikes. Extinctions feel distant, like stories from another world, but they are not distant to Earth. They are part of its breathing, part of its memory. There is something strangely comforting in this. Yes, the cycles are destructive, but they also show resilience. Life doesn't end. It changes. The planet doesn't give up. It adapts. Even if civilizations before us were erased, even if we too were someday erased, the Earth would continue to create again. The stage would not stay empty for long. Somewhere, somehow, new forms would rise. That is what the cycles guarantee. So as we wonder whether we're the first version of Earth or just the latest, the cycles whisper a reminder. Everything we build, everything we fear losing, is part of a larger rhythm. Creation and ruin are not enemies. They are partners. They shape one another, trading places over spans of time so vast we can barely comprehend them. And in their dance, life never truly stops. It just changes costume and begins another act. And here we are, standing in the middle of one act, uncertain how it will end, but aware now that endings are never as final as they seem. The ruins of today are the raw material of tomorrow. The cycle continues, and in that continuation lies both mystery and possibility. When people first hear the idea of forgotten civilizations, they often picture lost cities hidden under jungles, crumbling temples overtaken by vines, or perhaps ruins buried under sand, waiting for archaeologists with brushes and trowels to bring them back into the light. And in a sense, those kinds of forgotten places do exist. We've rediscovered whole societies that had slipped from memory. The Mayans, once thought to be scattered farmers until the jungle gave up the outlines of their great cities. The Indus Valley civilization, whose script still puzzles us. Göbekli Tepe in Turkey, thousands of years older than the pyramids, challenging our assumptions about when humans first built monumental structures. These are remarkable, but they are recent. They belong to the last 10,000 years, a blink compared to the age of Earth. The Forgotten Civilizations hypothesis asks something much bolder. What if the forgetting stretches not thousands of years, but millions? What if the Earth has already hosted civilizations before us, so long ago that their traces are gone or nearly gone? Not mythic Atlantis, but entire epochs of intelligent life erased by time, tectonics, and erosion. It is a question that borders on the fantastical, yet it's rooted in a real problem. Earth doesn't preserve evidence very well over deep time. The crust recycles, sediments erode, artifacts crumble. Even fossils, which feel so permanent to us in museums, are rare accidents of preservation. For every bone turned to stone, there are countless others lost forever. So what would it mean to take this hypothesis seriously? First, we would have to think about what kind of evidence could survive millions of years. A building? Unlikely. A road? Almost certainly not. A piece of pottery? Perhaps. But even pottery we make today erodes and shatters over just a few centuries when left exposed. Plastics might seem like durable markers, but in the long span of millions of years, even they would break down, perhaps leaving only a faint chemical signature in sediments. Metals corrode, glass weathers into grains. Nothing we make is immune to geological time. Instead, the best candidates for survival would be indirect. Chemical anomalies, isotopic oddities, sudden changes in the composition of rocks or sediments that can't be explained by natural processes alone. For example, If we disappear tomorrow, future geologists might find a layer rich in carbon from fossil fuel burning, traces of radioactive isotopes from nuclear activity, and unusual concentrations of metals from our industry. These would be subtle but detectable. If another civilization had once altered the Earth in similar ways, those are the kinds of fingerprints we might still find. This is the essence of the Silurian Hypothesis, a thought experiment proposed by two scientists not because they believed in ancient industrial civilizations, but because asking the question helps clarify how limited our own evidence would be if we vanished. Imagine a species 100 million years from now curious about us. What would they actually find? Maybe a thin layer of sediments showing a strange spike in carbon and plastics. Maybe traces of isotopes that don't occur naturally, but not much more. Our skyscrapers, our highways, our libraries, our digital clouds, all of it would be gone. That realization alone makes it harder to dismiss the possibility that others could have come before, erased just as thoroughly. Skeptics will point out quite reasonably that there is no evidence so far. Archaeology, paleontology, geology. None of these fields has uncovered anything that definitively points to pre-human civilizations. When odd artifacts do surface, they often turn out to be misidentified natural formations or more recent human creations. And absence of evidence is, as the saying goes, not evidence of absence. But the hypothesis is less about proving ancient civilizations existed, and more about recognizing how narrow our view of Earth's past really is. We are piecing together fragments from an enormous puzzle, most of which are missing. That leaves space for questions. It also forces us to think about what we mean by civilization. Our instinct is to imagine something like us. Cities, tools, art, machines. But what if intelligence took another path? What if it left marks that don't look familiar to us? Suppose a species developed complex societies, but worked with materials that decayed quickly, or built structures in ways that left no durable trace. Suppose their greatest achievements were biological rather than mechanical, altering life in ways we haven't yet recognized. Would we even know how to look for that? Then there's the matter of time itself. Civilizations don't need billions of years to vanish. Even 100,000 years, which is long by human standards, is a blink geologically. In that time, forests regrow, rivers shift, deserts advance, glaciers scrape the land clean, traces are buried or lost. If we imagine a civilization that lasted for tens of thousands of years, say 200 million years ago, what would remain today? Possibly nothing obvious, just a whisper in the rocks, if that. It's worth remembering that even our own record of ourselves is fragile. Most of human history is already lost. Oral traditions vanish when languages die. Wooden tools decay. Early settlements leave little behind once reclaimed by nature. Even in recorded history, vast archives have burned in wars, libraries have been destroyed, and knowledge has slipped through cracks. If that's true for just a few thousand years, the idea of losing millions of years of history becomes less absurd. This hypothesis also resonates with myths and stories. Many cultures have tales of worlds before this one, cycles of creation, floods, or fires that reset humanity. While we shouldn't confuse myth with geology, it is striking how often the theme of forgotten ages appears. Whether these are echoes of real events, like ancient floods remembered across generations, or simply metaphors for human fragility, they reflect a deep intuition that we may not be the first, and we may not be the last. Critics argue that extraordinary claims require extraordinary evidence, and so far we don't have that. They're right. But sometimes the absence of evidence highlights how poor we are at looking. We've barely scratched the surface of the ocean floor where sediments hold long histories. We've barely sampled the deepest layers of rock. We've only recently developed the tools to detect subtle, chemical, and isotopic signatures. Our search for past civilizations, if we ever take it seriously, has hardly begun. And even if the hypothesis is wrong, even if we are truly the first, The act of asking the question matters. It forces us to face the impermanence of our own achievements. It reminds us how fleeting civilizations are against the backdrop of geological time. It humbles us, showing that the planet's memory is vast but selective, and that we may be just as forgettable as any who might have come before. So the forgotten civilizations hypothesis is not really about proving that others lived here first. It's about perspective. It's about realizing that our dominance is not guaranteed, that our traces may be thinner than we imagine, that we're part of a cycle that may have played out before and may play out again. It is about seeing Earth not as a stage built for us, but as a restless recorder of countless acts, most of which it has already erased. And as we wonder whether civilizations before us were forgotten, we also wonder how we ourselves will be remembered, or if we too will become another layer in the silence of the rocks. The Silurian question has a curious origin. It doesn't come from geology textbooks or archaeological reports, but from science fiction. In the 1970s, a British television series called Doctor Who introduced reptilian beings called the Silurians, imagined as an ancient intelligent species that had evolved on Earth long before humans and then gone into hiding. The name stuck, not because scientists believed in reptilian overlords beneath the crust, but because it gave a convenient label to a thought experiment. Could there have been intelligent beings on Earth millions of years before us, a race so thoroughly that we have almost no chance of finding them? When Gavin Schmidt, a climate scientist at NASA, and Adam Frank, an astrophysicist, brought up the idea in a serious paper in 2018, they weren't suggesting that Doctor Who was right. They were asking what evidence an ancient industrial civilization, if it had existed, might leave in the geological record, and how we would recognize it. This became known as the Silurian Hypothesis. The Silurian question, then, is the broader challenge it raises. Are we certain we're the first, or is it just that Earth has erased all evidence of any predecessors? It might sound fanciful, but the reasoning is sober. Human industry has already altered the planet in measurable ways. We've released vast amounts of carbon into the atmosphere, created synthetic chemicals that don't exist in nature, mined and redistributed rare metals, and generated radioactive isotopes through nuclear activity. These changes are leaving a geological signature. If another species studies Earth millions of years from now, they will find this signature in the rocks and sediments. Not skyscrapers or smartphones, but chemical oddities that wouldn't exist without us. So if there had been an earlier civilization, these are the kinds of traces we should look for, and the Silurian hypothesis asks us to consider whether such traces already exist in the record, but have been misinterpreted as natural events. Earth's history is filled with spikes and anomalies, sudden warming events, strange chemical layers, abrupt extinctions. Most of these are explained as volcanic outbursts, asteroid impacts, or shifts in ocean circulation. But the Silurian question lingers. How can we be sure they're natural and not the faint echoes of something else? One of the events that often comes up in this discussion is the Paleocene-Eocene thermal maximum, about 56 million years ago. During this period, global temperatures rose by as much as 8 degrees Celsius in a relatively short time, and carbon levels in the atmosphere spiked. The cause is thought to be massive releases of methane and carbon dioxide, possibly from volcanic activity or the destabilization of methane hydrates in the oceans. But if you didn't know better, the chemical signals look remarkably like the ones we're creating now. The Earth heated quickly, ecosystems were disrupted, and it took hundreds of thousands of years for conditions to stabilize again. Could this have been the footprint of an earlier civilization? Almost certainly not, but the fact that it can't be immediately dismissed is what makes the Silurian hypothesis interesting. Another piece of evidence sometimes discussed is the presence of unusual isotope ratios in sediments. Nuclear activity produces isotopes that don't occur in large amounts naturally. If a civilization had split atoms on an industrial scale millions of years ago, traces might still exist in sediments. So far, none have been found. but the search hasn't been systematic. The Silurian question encourages scientists to think about where and how to look. Ocean sediments are one promising place, since they build up steadily over millions of years and can capture chemical traces with remarkable precision. Skeptics are quick to point out that extraordinary claims require extraordinary evidence, and so far the Silurian hypothesis hasn't provided any. There's no sign of fossilized cities, no advanced artifacts buried in ancient strata, no definitive chemical signals that can't be explained by natural causes. But the point isn't to prove there were ancient civilizations. It's to highlight how incomplete the geological record is, and how easily the signs of human activity could be erased over deep time. If we vanished tomorrow, in 10 million years the evidence of our existence would be reduced to a thin, ambiguous layer, easily misread as volcanic activity or some other natural event. The Silurian question also forces us to rethink what we mean by civilization. When we imagine predecessors, we tend to picture beings like us, tool users, builders of cities, masters of fire and metal. But intelligence could have taken other forms. Maybe it wasn't based on tools at all. Maybe it expressed itself through biological manipulation, altering ecosystems in ways we might not recognize as artificial. Maybe it rose in the oceans rather than on land, leaving behind chemical changes in marine sediments rather than stone ruins. We can't assume that intelligence always looks like us. What makes the Silurian question valuable is not that it suggests reptilian scientists once roamed the Earth, but that it broadens our imagination. It reminds us that our species occupies only the latest fraction of Earth's history. Complex life has existed for hundreds of millions of years. That's a long time for opportunities to come and go. If intelligence is possible, why should it have appeared only once? And if it appeared before, why should it have lasted any longer than we might? There's also a cosmic perspective. Astrobiologists, who study the possibility of life beyond Earth, often wonder how likely it is for civilizations to arise elsewhere. One of the puzzles they face is the Fermi paradox. If the universe is so vast and old, where is everyone? The Silurian question offers one possible clue. Maybe civilizations are common but fragile. Maybe they flare up, leave brief chemical signatures, and then vanish, their traces swallowed by planets that recycle themselves. If we can't even be sure whether Earth itself hosted others before us, how can we expect to find easy answers among the stars? Of course, the Silurian hypothesis hasn't convinced the scientific community that forgotten civilizations exist. Most researchers see it as a thought experiment rather than a claim, but that's what makes it valuable. It encourages scientists to test their assumptions, to refine their tools, and to think carefully about what kinds of evidence civilizations actually leave behind. It pushes us to recognize how much of Earth's history is invisible to us, and how easily we might be erased. The Silurian question, then, isn't really about reptiles from television. It's about humility. It asks us to admit that our knowledge of the past is incomplete, that our confidence in being the first may be misplaced, and that even if we are unique, we are not permanent. Earth has seen countless rises and falls, and whether or not they included civilizations, we're simply the latest expression of a planet that constantly reinvents itself. And as we think about those possibilities, we can't help but look forward as well as back. If another species one day wonders about us, what will they find? Will our chemical signature be obvious, or will it blend into the noise of natural cycles? Will our memory be erased, leaving them to ask the same questions we're asking now? The Silurian question is not just about what might have been. It's about what will remain of us when our time has passed. When we think about history, we often imagine it as a long shelf of books. Each volume holds a record of events, written down, preserved, waiting to be read. But Earth doesn't keep its past like a library. It keeps it like a chalkboard. It writes in stone, yes, but it also erases with the same hand that writes. Time, on this planet, is the great eraser. It leaves some things behind, but most are wiped away, smudged, or rewritten until the original markings are gone. This isn't just an idea. It's the reality of geology. Consider the continents we live on. The ground under your feet feels permanent, but it isn't. Tectonic plates are constantly moving, colliding, pulling apart and sliding past one another. Oceanic crust in particular is temporary. It forms at mid-ocean ridges, spreads outward, and eventually plunges back into the mantle at subduction zones. The average age of ocean floor is only about 200 million years. To us that sounds unimaginably old, but compared to the planet's 4.5 billion year history, it's like fresh paint. That means if a civilization once thrived on land that later sank beneath the sea, its traces would have been recycled long ago into magma, erased without a whisper. Even the continents, which are older and more stable, do not keep perfect records. Erosion wears them down. Rivers grind mountains into sand. Wind strips rock to dust. Glaciers scrape valleys clean. Layer upon layer is deposited, tilted, buried, folded, and sometimes melted entirely into new rock. In this restless cycle, most traces vanish. Fossils survive only under very specific conditions. Artifacts of wood, bone, or cloth almost never last more than a few thousand years unless they are buried in exceptionally dry or frozen environments. Metals corrode, plastics degrade, glass shatters, and weathers into grains. Over millions of years, even the strongest materials become unrecognizable. That is what makes deep time so humbling. We think of our world as full of monuments, technologies, and structures too massive to disappear. But time is patient. It doesn't need to knock things down all at once. It can wait. Given enough years, skyscrapers become rubble, rubble becomes sediment, and sediment becomes stone. In the end, the Earth itself swallows what we leave behind. That is why we find so few traces of the creatures that lived before us. Not because they didn't exist, but because time has been busy erasing them. Even when traces do survive, they are rarely complete. Think about the dinosaurs. They lived for over 150 million years, spreading across the globe, filling every niche from tiny bird-like creatures to enormous sauropods longer than buses. And yet, our fossil record of them is spotty. We have bones here and there, tracks frozen in mud, feathers preserved in amber. But for all their dominance, what remains is a collection of fragments. Imagine trying to reconstruct human civilization in the distant future from a handful of crumbling skyscrapers and a few scattered tools. That's what paleontologists do every day, piecing together entire worlds from scraps that escaped the eraser. And if that is the case for creatures as massive and widespread as dinosaurs, what chance would a more delicate civilization have? If there were intelligent beings in the deep past, their record could be far thinner than that of animals who left behind bones and teeth. Civilizations build with intention, but intention doesn't guarantee permanence. Cities of steel and glass seem strong to us, but they are no match for the slow persistence of weather, water, and tectonics. Time does not need to hurry. It erases at its own pace. The Great Eraser doesn't just act on land. The oceans are perhaps the most thorough of all. Shipwrecks sink and scatter. Organic remains dissolve or are consumed. Sediments cover the rest. Within centuries, wooden ships vanish almost entirely. Even metal ships corrode to little more than shapes. If you stretch that timeline to millions of years, the ocean floor becomes as clean as a blackboard wiped down after class. Whatever had been there before is gone, unless it happens to be preserved in a stable, quiet layer of sediment. This is why the Silurian Hypothesis strikes a chord. When scientists asked whether we could find traces of a civilization millions of years old, they weren't saying we should expect fossilized cities. They were admitting how thorough time's eraser can be. The odds of durable artifacts surviving long spans are slim. What we might detect instead are subtle chemical fingerprints, faint anomalies that survived where stone and steel could not. Even then, we can't be sure whether those anomalies point to life, industry, or simply nature itself. What's fascinating is how selective this eraser can be. It doesn't clear everything equally. Certain things survive better than others. Bones rich in minerals buried quickly can become fossils. Insects trapped in amber can endure for tens of millions of years in astonishing detail, right down to the veins of their wings. Footprints hardened in mud can outlast the animals that made them, but whole forests, whole cities, whole civilizations, unless preserved under the rarest of conditions, they dissolve into absence. This uneven record is why paleontology and archaeology require so much interpretation. We're not reading a complete story. We're reading whatever escaped the eraser, filling in gaps with careful inference, and sometimes we may be wrong. Sometimes what we call natural might once have been cultural, or vice versa. Time blurs the lines until certainty becomes elusive. For humans, this erasure has always been unsettling. We want permanence. We build monuments like the pyramids, the Great Wall, Stonehenge, not just for function but for memory. We carve names in stone to resist forgetting. Yet even these fade. Wind rounds the edges, rain wears down inscriptions, earthquakes topple walls. Given long enough, even the most ambitious structures will be dust. The eraser is impartial. It cares nothing for pride or glory. It works on kings and commoners alike, on skyscrapers and sandcastles without distinction. There is, however, a paradox in this. While time erases most things, it also highlights the few that remain. That is why fossils feel so precious, why ruins inspire awe, why fragments matter. They are survivors of erasure, small pieces of a larger story that once was. Their rarity makes them powerful. Each one is a reminder that the past was vast and lively, even if we can see only faint glimpses of it now. So when we ask whether earlier civilizations might have existed, we're really asking how much confidence we can have in the fragments that escaped. The answer, honestly, is not much. Our evidence is fragile, incomplete, and constantly at risk of vanishing further. Time's great eraser works slowly, but it never stops. What it leaves behind is chance more than intention. That means the absence of evidence is not always the evidence of absence. It may simply be the mark of an eraser doing its work too well, and yet this eraser has another side. It makes room for renewal. By clearing away the old, it allows the new to emerge. The forests that grow after glaciers retreat, the coral reefs that rise after seas shift, the civilizations that build on the ruins of others. All of these depend on erasure. Time clears the board so that life can write again. What feels like loss is also preparation. Without erasure, there would be no space for creation. Without ruin, no rebirth. In this way, the eraser is not cruel, just impartial. It ensures that nothing dominates forever, that change remains constant, that history never freezes. For us, it means accepting that we too will one day be erased. Our monuments, our cities, even our names will fade. But the world will continue, ready for whatever comes next. And in the faint memories the earth does keep, there will still be hints of us. Not perfect, not complete, but enough to whisper that we were here for a while, before the eraser smoothed the page and the story moved on. When we think of the past, we tend to picture it written in stone, fossils pressed into rock, bones turned to minerals, layers of sediment stacked like dusty archives. But the air carries memories too, and sometimes those memories are even more revealing than the ground beneath our feet. The atmosphere is not just a space we move through, it is a record keeper, a chemical historian, and a silent witness to what life has done on this planet. If we want to know whether others came before us, one of the most important places to look is not beneath our feet but above our heads, in the thin shell of gases that surround the Earth. Air is a subtle medium, but it has an astonishing capacity to record change. Every time we burn fuel, we leave traces in the form of carbon dioxide. Every time a volcano erupts, it releases sulfur compounds that linger for years, sometimes decades, in ice layers or sediments. Even dust storms carry signatures, moving minerals from one continent to another, leaving clues about climate and ecology. Over millions of years, much of this information disappears, but some of it is preserved, frozen in ice, trapped in sediments, or absorbed into rocks. Scientists can read these clues like detectives following faint tracks across an ancient field. One of the clearest examples is the way ice cores preserve air bubbles. In Greenland and Antarctica, researchers drill deep into the ice, pulling out cylinders of frozen history. Each layer of ice corresponds to a snowfall, compacted year after year, century after century. Within those layers are tiny bubbles of atmosphere, perfectly sealed since the day they were trapped. By analysing them, scientists can measure carbon dioxide levels, methane concentrations, even traces of ancient volcanic eruptions. Some cores stretch back hundreds of thousands of years, giving us a remarkably detailed view of Earth's climate over that span. These records show us when ice ages began and ended, when carbon spiked, when temperatures rose or fell. They prove that air, for all its invisibility, remembers. If a civilization had altered the planet millions of years ago, perhaps it too left its mark in the atmosphere. Industrial activity changes air in ways that nature rarely does. The combustion of fossil fuels, for example, produces carbon with a distinct isotopic fingerprint. Plants prefer lighter isotopes of carbon, so fossil fuels, which come from ancient plants, are depleted in the heavier isotope carbon-13. When we burn them, the atmosphere's ratio of carbon-12 to carbon-13 shifts. Scientists today use this as proof that rising carbon dioxide is largely human-driven. If another civilization had done the same, even millions of years ago, it might have left a similar isotopic signal for us to find. There are other, even stranger, clues. Nuclear activity produces isotopes that are virtually absent in nature, like plutonium-244 or certain forms of uranium. Some of these isotopes have half-lives long enough that traces could persist in sediments for millions of years. Synthetic chemicals like chlorofluorocarbons, CFCs once used in refrigeration and aerosol sprays, also have no natural source. If we vanish tomorrow, these molecules would eventually break down, but they might leave chemical ghosts in soils and sediments. And if another civilization once altered their air with similarly unnatural compounds, hints might remain in the geochemical record. The problem is that air, unlike rock, is fleeting. It mixes, it disperses, it changes constantly. The atmosphere is restless. Storms churn it. Winds carry it around the globe. Over long spans of time, gases are absorbed into the ocean or fixed into minerals. What remains are only those traces that happen to be caught and preserved. That makes the search difficult, like trying to reconstruct a book when all you have are a handful of letters scattered in a bottle of water. Yet those letters are powerful, because they prove that even the invisible can leave lasting memories. One of the most dramatic atmospheric events in Earth's history was the Great Oxidation Event, about 2.4 billion years ago. Before that time, Earth's air was largely devoid of oxygen. Then, cyanobacteria, tiny organisms performing photosynthesis, began releasing oxygen as a byproduct. Over millions of years, this changed the atmosphere permanently, paving the way for complex life. We know this happened not because we were there, but because rocks from that time show sudden changes in their chemistry. Iron formations, sulfur isotopes, and other geochemical signatures reveal that oxygen surged and transformed the planet. In other words, life left fingerprints in the air, and the Earth kept them. That example matters because it shows how much impact biology can have on atmosphere, and how long those impacts can last. If microbes could alter the air so profoundly billions of years ago, is it really so impossible to imagine that an intelligent civilization might have done something similar much more recently? We're doing it now, after all, in ways that geologists of the far future will likely see as a sharp, unnatural spike. If Earth holds memories of oxygen from billions of years ago, then perhaps it could also hold memories of industrial activity from tens of millions of years ago, if it ever happened. But here lies the difficulty. Natural processes also leave strange atmospheric marks. Volcanoes can raise carbon levels dramatically. methane can leak from clathrates on the seafloor. Even asteroid impacts can pump odd chemicals into the sky. To tell whether an anomaly in the air came from natural events or industrial ones, scientists need multiple lines of evidence. One signature alone is not enough. The challenge is distinguishing fingerprints in a world where nature often smudges and overlaps them. That is why the search for atmospheric clues is both fascinating and frustrating. We know the air carries history, but we also know how fragile that history is. We can see clear records in ice cores stretching back hundreds of thousands of years, but beyond that things get fuzzier. Sediments and rocks hold some of the older evidence, but it's fragmentary. If civilizations existed tens of millions of years ago, their atmospheric marks might be faint, buried, or lost entirely. The eraser of time works on air as much as it works on stone. Still, the possibility keeps the question alive. If air can remember oxygen from billions of years ago, it might remember industry from a forgotten age. If we know how to look, we might one day find anomalies that don't fit neatly into our catalogue of natural causes. And even if we never find such evidence, the act of searching gives us perspective. It reminds us that the air we breathe is not just for us. It is part of a story that has been unfolding since the beginning, carrying traces of every fire, every eruption, every breath that life has ever taken. And of course, it reminds us that we ourselves are writing in that story right now. Our cars, our factories, our power plants, our choices, all of them are leaving chemical words in the atmosphere, words that future beings may one day read. The air is recording us, just as it recorded volcanoes, microbes and glaciers. Whether we want it to or not, our age is being written into the thin blue film above our heads, waiting to be remembered, even as time works to blur the ink. If you want to find Earth's most patient archive, you don't look at mountains or deserts or even ice. You look at the oceans. Beneath those restless waves, in the quiet darkness of the seafloor, lies a library of mud and silt that has been collecting pages for millions upon millions of years. Each layer settles gently, one on top of another, trapping tiny fossils, grains of dust, chemical traces and fragments of the atmosphere. These sediments are messages in the deep, and they may be the best place to look if we ever hope to find evidence of forgotten chapters in the story of Earth. It's almost ironic. The surface of the ocean feels so empty, so transient, changing with every wind and tide. Yet the bottom is one of the few places where the planet's memory is steady and continuous. Year by year, century by century, sediments rain down. The skeletons of plankton, the dust of continents, the ashes of distant volcanoes, even the faint fallout of cosmic events. What seems like endless water is actually a vast conveyor belt of memory, writing slowly in mud. Scientists use drills mounted on research ships to extract cores from this archive. These cores are long cylinders of sediment, each one a timeline stretching back thousands, sometimes millions of years. By analysing the chemistry, fossils and isotopes within them, researchers can reconstruct ancient climates, ocean temperatures, and even the composition of the atmosphere. It's through these deep-sea records that we've learned about ice ages, warming events, and mass extinctions. They're fragile, but they hold details no stone or fossil on land could preserve. That makes the deep ocean an especially intriguing place for the Silurian Hypothesis. If a civilization altered the planet millions of years ago, the seafloor might be where its fingerprints still linger. Industrial activity doesn't just change the land. It changes the oceans. Carbon emissions dissolve into seawater, altering its chemistry. Pollutants accumulate in sediments. Rare earth metals, plastics, synthetic compounds. All of these eventually make their way into the marine environment. If we disappeared tomorrow, the seafloor would quietly record the story of our presence long after our buildings had crumbled. Consider plastics. They're so widespread now that scientists have coined a term, plastiglomerate, for rocks that contain melted plastic fused with sand, shells and lava. These strange hybrids are forming along coastlines where plastic waste has been burned or melted and then mixed into natural materials. In the far future, these plastiglomerates may be one of the clearest markers of our age, preserved in sediments long after the original bottles and bags have degraded. If another civilization had produced anything like plastics, perhaps there are similar strange composites buried deep beneath the ocean floor waiting to be recognised. Or take heavy metals. Mining and industry redistribute elements in ways that nature rarely does. Lead, mercury, chromium, rare earths, all of these can concentrate in sediments where rivers carry them to the sea. Future geologists could detect our influence by the unusual spikes of these metals in marine layers. If there were earlier industrial societies, perhaps their mining, smelting, or energy use left comparable signals. We might mistake them for volcanic fallout or meteor dust, but the possibility lingers that some anomalies we already see could be cultural rather than natural. The deep ocean also preserves biological messages. When plankton die, their shells settle to the bottom. The chemistry of those shells records the conditions of the water they lived in: temperature, acidity, nutrient levels. By examining layers of these microfossils, scientists can reconstruct ancient oceans in detail. If industrial activity once altered the climate or chemistry of the seas, it might show up in these tiny skeletons. Sudden shifts in growth, changes in species abundance, or strange chemical imbalances could all be signs of something unusual happening on the planet's surface. Of course, the challenge remains the same. Natural events can mimic industrial ones. Massive volcanic eruptions can flood the oceans with metals and alter their chemistry. Asteroid impacts can scatter dust and trigger die-offs. Climate shifts can change species abundance dramatically. Sorting out what is natural and what could be artificial is not simple. The messages in the deep are clear in their details, but they don't come with captions. They are records, but not explanations. We are left to interpret, and interpretation always leaves room for doubt. That doubt is what keeps the question alive. If we find a sudden spike in carbon millions of years ago, is it a volcanic pulse or the exhaust of machines? If we find unusual isotopes, are they fallout from an impact or the remains of nuclear technology? If we find odd composites in sediments, are they natural accidents or artificial inventions? The evidence can look the same, and without context the truth is hard to pin down. But even if we never find clear signs of ancient civilizations, the deep sea still teaches us humility. It shows how fleeting our own presence is compared to the patient accumulation of sediments. It shows that what we consider permanent is just another layer waiting to be buried. It reminds us that the ocean is not just a backdrop for our lives, but a recorder of them, silently taking notes while we go about our business. And there's a strange comfort in knowing that even if our cities vanish, even if our artifacts crumble, the deep will remember us. In the mud and silt, in the chemistry of shells, in the quiet accumulation of layers, traces of our age will endure. Future beings, if they ever go looking, will find those messages and know that something was here. Something that burned carbon, made plastics, mined metals, and changed the oceans in ways nature alone never would. Perhaps the most humbling thought is that the deep sea may already hold messages like these, not from us, but from others long gone. If civilizations rose and fell millions of years ago, their last whispers may be buried in sediments we haven't yet studied, waiting for a careful eye to notice that something doesn't quite add up. Until then, the messages remain silent, the pages closed, the archive hidden beneath miles of water and darkness. But the ocean is patient. It doesn't rush to reveal its secrets. It waits, layer by layer, for those who are willing to listen. And in that waiting, it reminds us that our time too will eventually sink into silence, another message in the deep. When you look at Earth from above, in photographs taken by satellites or astronauts, it seems whole and unchanging. A blue sphere with swirling clouds, green and brown continents, white patches of ice. From that view, It looks permanent, almost serene. But the truth is, the Earth is restless. Beneath that calm appearance is a planet constantly recycling itself, renewing its skin, reshaping its landscapes, and hiding the traces of whatever came before. If civilizations once stood here long before us, their remains would have faced not just time's eraser, but the Earth's habit of rewriting itself from the ground up. The most obvious way this happens is through plate tectonics. The crust of the Earth is not a solid shell, but a mosaic of plates that float atop the mantle. They move slowly, only a few centimetres each year, but over millions of years that pace is enough to rearrange entire continents. Oceans open and close, mountains rise and wear away, land masses drift from pole to equator and back again. In the process, oceanic crust is constantly being created at mid-ocean ridges and destroyed in subduction zones. This cycle means the ocean floor is never more than about 200 million years old. If a city once stood on what is now the seafloor, it has already been swallowed, melted, and reborn as new crust somewhere else. Even continents, which are older and more durable, cannot escape recycling. They're fractured, uplifted, and eroded again and again. Sediments wash into seas and are compressed into stone, then lifted back into mountains only to crumble once more. What survives are fragments, old cratons of continental crust that have resisted recycling, but even these are weathered and reshaped. The story they tell is full of gaps, like a book with missing chapters. For every fossil we find, for every rock layer we study, countless others have been erased by the planet's own processes. This recycling has a creative side too. It enriches soils, forms new minerals, and drives the carbon cycle that stabilizes Earth's climate over long spans of time. Without tectonics, life as we know it might never have flourished. The steady renewal keeps the planet habitable, but it comes at a cost to memory. The more dynamic a planet is, the harder it is to read its past. Venus, with its surface resurfaced by volcanic activity, shows almost no geological record older than a few 100 million years. Earth is better at keeping some records, but it too rewrites constantly, burying the past beneath new pages. This is why the search for evidence of forgotten civilizations is so difficult. It's not that they couldn't have existed, it's that Earth doesn't hold on to its history very well. If humans vanished today, in 100 million years most of our record would be gone. Even our plastic, which feels like such an unnatural marker, would be broken down and buried. Perhaps a few chemical signatures would remain, but they would be buried in sediments that might themselves be uplifted, eroded, or subducted into the mantle. Future geologists would find only ambiguous hints. The rest would have been recycled into something new. The idea that planets recycle themselves isn't unique to Earth. Mars, though less active now, once had volcanoes so large they dwarf anything on our world. Olympus Mons, the tallest volcano in the solar system, is a reminder that even a planet that looks quiet today was once reshaped by fire. Venus has evidence of resurfacing events that may have erased most of its ancient geology. Even the Moon, though it lacks plate tectonics, has been endlessly recycled by impacts, with craters overlapping craters in a palimpsest of violence. Planets are not static. They are machines of renewal, each in their own way. But Earth is especially thorough. Its oceans erase history quickly. Its weather grinds away evidence. Its tectonics devour crust whole. That makes our window for detecting ancient traces very narrow. If earlier civilizations existed, they would have had to leave something extraordinarily durable to survive the recycling. A monument carved into the stable cratons of continental interiors, perhaps, or a chemical signal so unusual it could not be mistaken for natural processes. Otherwise, the recycling machine would have done its work, and all that remained of them would be folded back into the planet, indistinguishable from the rest. This realization carries a kind of humility. We are not just temporary on the scale of time. We are temporary on the scale of geology. Our most ambitious creations, the towers and tunnels we think of as permanent, are already on borrowed time. Eventually the Earth will recycle them, just as it has recycled everything before us. The question is not whether it will happen, but how long it will take. There's also a kind of reassurance in that. If ruin is inevitable, it is also not personal. Earth is not singling us out. It has always recycled itself, and it always will. The continents you see today are not the continents of the past, nor will they be the continents of the future. They are temporary arrangements, shifting pieces in a puzzle that is never finished. We happen to live on them now, but long after we are gone, they will have moved, collided, and remade themselves again. For those who dream of permanence, this can feel discouraging. But for those who value renewal, it can feel like a promise. Recycling ensures that no mistake lasts forever. Even the scars of industry, even the damage we do will one day be smoothed away. That does not mean we should be careless. Our choices matter profoundly in the near term, but it does mean that Earth itself is resilient. It can recover, reshape, and begin again. The recycling machine, while merciless to memory, is kind to life's persistence. And so, when we wonder whether we're the first version of Earth, we're really asking whether anyone else left traces strong enough to survive this relentless recycling. If they did, those traces may still be hidden, waiting to be found in stable rocks or deep sediments. If not, then Earth has done what it always does, wiped the board clean and handed the chalk back to life, ready for another attempt. When we think about technology, we usually imagine it as something shining and obvious. Skyscrapers lit against the night sky, satellites orbiting above us, vast machines digging, refining, assembling. Technology feels like the most visible marker of our age, the one thing that truly separates us from the rest of Earth's story. But if we step back and think in terms of geological time, technology may be more shadow than monument. It appears briefly, leaves faint traces, and then vanishes almost completely. What we think of as permanent progress may, in the scale of millions of years, be little more than a ripple across the surface of the planet. This is why the question of lost technologies is so difficult to answer. If an earlier civilization developed machines, tools, or entire industries, what would remain of them today? We like to imagine intact artifacts, devices waiting to be discovered, but reality is harsher. Metals corrode. Iron rusts to dust. Copper turns green, then crumbles. Even stainless steel, so resistant in our daily lives, breaks down in centuries when left exposed. Glass shatters, weathers, and eventually dissolves back into sand. Plastics, for all their reputation of permanence, degrade under sunlight and pressure, fragmenting into particles too small to be recognized as artifacts. In a million years, none of these would look like technology. They would look like minerals, sediments, or faint chemical oddities. There's also the scale problem. Technology for us means massive global systems, but for the Earth, even our largest structures are tiny. The Great Wall of China, visible from space to human eyes, is a mere scratch compared to a mountain range. Cities that seem enormous to us are minuscule compared to continental shifts. Our most durable works, like pyramids or concrete dams, are still fragile when weighed against glaciers, floods, earthquakes, and the steady grind of erosion. If earlier civilizations built wonders of their own, they too would have been erased, their stones scattered, their metals returned to dust. Yet shadows of technology might remain, if not the objects themselves, then the effects they had. This is where the idea of technosignatures becomes important. Even if machines vanish, the processes they set in motion can leave long-lived marks. Our age, for example, will likely be remembered not for its buildings, but for its chemistry. The burning of fossil fuels leaves carbon isotopic shifts. Nuclear activity leaves rare isotopes that linger in sediments. Mining redistributes elements in unnatural concentrations. Synthetic compounds, plastics and fertilizers alter soils and waters in ways that nature alone would not produce. These are not artifacts in the traditional sense, but they are shadows of technology, fingerprints that remain after the machines are gone. If another civilization existed millions of years ago, these are the kinds of shadows we might hope to find. Not intact devices, but chemical anomalies. Not monuments, but disrupted cycles. Perhaps a sudden layer in the geologic record rich in certain metals. Perhaps isotopic ratios that don't fit natural explanations. Perhaps microfossils showing sudden stress from pollutants that should not have been there. These would not shout technology to us, but they would whisper that something unusual happened, something that hints at intelligence. The question, then, is whether we've already seen such whispers and simply interpreted them as natural. There are warming events in the deep past, spikes of carbon, layers of unusual materials. Most are explained as volcanic outbursts, methane releases, or impacts. But could a few be the shadows of lost technologies? We can't rule it out entirely. That is why the Silurian Hypothesis was framed not as a claim but as a challenge. If technology leaves such subtle shadows, how would we tell them apart from geology? There's another side to this, one that touches on our own future. If our technology can vanish so quickly, what does that say about the permanence of our achievements? We think of the digital cloud as endless, yet the servers it depends on will fail within decades without maintenance. Books burn, records fade, data storage devices become unreadable. Even knowledge itself, if not passed on, disappears. The shadow of our technology is chemical, not cultural. The stories we tell may vanish, but the carbon, isotopes, and altered sediments will endure. That will be our most lasting message to the future, whether we like it or not. And perhaps that has always been true. If earlier civilizations rose and fell, their knowledge, their stories, their identities are gone. What might remain are only shadows, changes in air, soil, or water that don't fit the usual rhythms. The shadow of technology is not about artifacts but about influence, not about machines but about their footprints. It is faint, but in a world that recycles itself constantly, faint may be the best we can hope for. The idea of shadows also forces us to think differently about intelligence itself. What if a civilization developed technology unlike ours, using materials that left no long-lived trace? What if they worked with biology, altering genes, shaping ecosystems in ways that appear to us as natural evolution? What if their greatest achievements were invisible to geology? In that case, even the shadows might be hidden, blended seamlessly into the story of life. We might be living in a world shaped by past intelligence without ever realizing it. That possibility is unsettling, but it also broadens the imagination. It reminds us that intelligence does not have to leave behind skyscrapers or satellites. It may leave subtler marks, it may fade more completely, and if so, then the shadows of lost technologies are not just chemical hints in rocks, but also mysteries in biology, ecology, or even myth. They may be all around us, but indistinguishable from the rest of Earth's history. For humans today, the lesson is twofold. First, we should not assume we're the first to walk this path. The shadows may already exist, faint and overlooked. Second, we should recognize how fleeting our own presence will be. Technology feels solid while it is in our hands, but in the eyes of the Earth, it is a passing shadow. What will remain of us is not what we built, but what we changed. The planet will keep those changes in its memory, even as the machines that made them are long gone. So the question of lost technologies is not really about whether someone before us had machines like ours. It is about recognizing that technology, no matter how advanced, is temporary. Its artifacts vanish, its details are forgotten. What endures are the shadows, faint fingerprints in stone, water, and air. And if we want to know whether others came before us, those are the marks we must learn to read. When we picture fossils, we tend to imagine a crowded record, a gallery of bones and shells laid out neatly for us to study. Museums reinforce that picture, with skeletons reconstructed and displays filled with delicate imprints of leaves, trilobites, or ammonites. But this image is misleading. The fossil record is not full, it is mostly empty. For every skeleton preserved, countless others have vanished. For every leaf pressed into stone, entire forests have disappeared without leaving a single trace. Fossilization is rare, and the silence it leaves is louder than the specimens we have. That silence matters because it shapes what we think we know about the past. When paleontologists reconstruct ancient worlds, they are working with fragments, most of them incomplete. A jawbone here, a tooth there, a handful of impressions, a scattering of shells. From these scraps, entire creatures and ecosystems are imagined, but the gaps are immense. It is like trying to reconstruct a library from a few torn pages scattered in the wind. The silence in the fossil record is not just a lack of information. It is a reminder of how much we don't know, how much has been erased, and how easily entire stories can vanish. Consider the dinosaurs. They dominated Earth for over 150 million years. They spread across every continent, filled every ecological role, grew to sizes no land animals before or since have matched. And yet, compared to the billions of individual animals that lived, the fossils we have are astonishingly few. The record is patchy, uneven, biased towards certain environments and conditions. We know them because some of their bones were buried quickly, protected from scavengers and weather, and then mineralized under the right circumstances. Most were not. Most dissolved, decayed, or were scattered long before they could ever fossilize. Even with such a dominant group, the silence outweighs the evidence. Now imagine something smaller, less widespread, or less likely to fossilize. The silence grows deeper. Soft-bodied creatures rarely fossilize at all unless preserved under exceptional conditions, like an amber or a noxic mud. Early human ancestors are known from only a handful of partial skeletons and teeth. Entire lineages may have existed and vanished, leaving almost nothing behind. If we already know that for the history we do study, what does that mean for the possibility of civilizations older than ours? Their remains might have been erased almost entirely, swallowed by the silence. This is what makes the fossil record so challenging. It is not a continuous story. It is more like a set of snapshots, taken at random, with most of the pictures missing. Sometimes those snapshots line up clearly enough to give us a sense of continuity. Other times, we see sudden gaps, abrupt disappearances and puzzling appearances. Species seem to vanish without explanation. New ones arrive without clear ancestors. We fill the gaps with theories, evolution, migration, extinction events. But we always know that the silence is there, waiting, reminding us that we may be missing something essential. In the context of forgotten civilizations, the silence becomes even more important. If a species built cities millions of years ago, would we expect fossils of their bodies? Possibly not. If their population was small compared to the vast herds of herbivores and predators around them, the odds of fossilization would be low. If they lived in regions not conducive to preservation, forests, wetlands, coasts, their remains would decay quickly. Even if a few individuals fossilized, we might never find them. They could be buried deep under layers we have not yet uncovered, or destroyed by tectonics, erosion, or subduction. The silence of the fossil record could easily swallow an intelligent species whole. Some might argue that if intelligent beings existed, we would surely have found more evidence by now. But consider how recently we've found some of our own ancestors. The first fossils of Homo floresiensis, a tiny hominin species, were discovered only in 2003 on the Indonesian island of Flores. They had lived just tens of thousands of years ago, yet their existence was completely unknown until then. How many other species, even relatively recent ones, have we simply not found? The silence is not just in the deep past, it extends into the near past too. That silence is also selective. Fossilization favours the durable, teeth, bones, shells. It disfavours the fragile, wood, fabric, skin, feathers, and certainly the tools and artifacts of civilizations if they were made of perishable materials. A wooden hut leaves no fossil. A woven basket leaves no trace. Even stone tools, unless preserved in the right context, are indistinguishable from natural rocks. If an early civilization used materials like these, their world could vanish without a sound. We assume that technology leaves durable remains, but that is our perspective. It might not have been true for others, and even when fossils do survive, interpretation is difficult. A strange mark on a bone could be the result of a predator's teeth, or it could be a tool mark. A pile of stones could be a natural formation, or it could be a collapsed structure. Without context, certainty is elusive. The silence in the record amplifies that uncertainty, because with so little evidence, each fragment carries too much weight. We build narratives from scraps, and sometimes those narratives may be wrong. But perhaps the most profound silence is not in the lack of fossils, but in what we assume from their absence. We tend to think that because we haven't found evidence, nothing was there. Yet silence is not proof of emptiness. It is simply an absence of sound. The fossil record is silent on vast stretches of Earth's history. It tells us something here and there, but between those whispers are eons of unrecorded life. For all we know, entire experiments in evolution, entire paths of intelligence, rose and fell in those gaps. They may have left no fossils, no artifacts, no traces that survived the erasing power of time. The silence does not rule them out, it simply leaves the question open. For us, living in the present, the silence has another meaning too. It reminds us of our own vulnerability to being forgotten. We assume that our skeletons, our tools, our buildings will tell our story long after we are gone. But the fossil record suggests otherwise. Most of what we are will vanish. Most of what we make will dissolve. In 1,000,000 years, the silence will cover us as it has covered so many before. Perhaps a fragment will survive. A tooth here, a shard of pottery there, a chemical layer in sediments. But that will be all. We will be mostly silent, and that is why the fossil record is both humbling and haunting. It shows us the richness of life that came before, but it also shows us the vastness of what we'll never know. It gives us glimpses but hides the majority. It is as much about what is missing as about what is present, and in that silence we are free to imagine, not recklessly but carefully, that perhaps we are not the first, and perhaps we will not be the last. When we picture engineers, we usually imagine hard hats, blueprints, machines and cranes lifting beams into place. That's what engineering looks like to us in this age. But when we turn the question toward the distant past and wonder about civilizations that might have risen and fallen long before us, imagining their engineers becomes far more difficult. What would they have built? How would they have shaped their world? And most importantly, what traces of their work could possibly survive the erasing hand of time? To even begin imagining ancient engineers, we first have to admit that our own vision of technology may be too narrow. We assume that intelligence must look like ours, that engineering must mean machines, metal and stone. But perhaps earlier intelligence worked with different materials, or had different priorities. Maybe they weren't builders of towering monuments, but shapers of ecosystems, biologists before biologists, altering living systems rather than erecting physical structures. Maybe their greatest works were invisible to geology, hidden not in stone but in genes, in the patterns of life itself. Still, it's worth asking. If they did build in ways we'd recognise, what might have lasted? Our first instinct is to think of stone, since stone monuments are among the few human creations that can endure for millennia. The pyramids of Egypt, Stonehenge, the megaliths of Easter Island. These are examples of human engineering that still stand thousands of years later, but scale them up to millions of years, and even stone begins to crumble. Weather, earthquakes, glaciers, and erosion wear it away. The odds of anything lasting intact across such spans are slim. Yet perhaps, in some forgotten corner, deeply buried or uplifted by tectonics, fragments of such ancient engineering could remain, waiting for discovery. Then there's the possibility of metal. Metals are central to our own engineering, but they corrode relentlessly. Iron rusts, copper tarnishes, aluminum oxidizes. Over a few centuries or millennia, most metal structures would vanish. Still, under special conditions, sealed away from air and moisture, buried deep in sediments, some remnants might endure. If ancient engineers mined metals on a large scale, that too could leave traces, not in artifacts but in the unusual concentrations of ores missing from certain deposits. A civilization that dug deeply into Earth's crust might have left behind scars in the geological record that don't quite align with natural processes. But perhaps the most intriguing possibility is that their engineering was not about monuments at all. What if their great projects were invisible, designed to blend into the world rather than rise above it? They could have shaped rivers, redirected coasts, cultivated forests in patterns we no longer recognize. Over time, these changes would fade back into nature, their artificiality lost. Yet sometimes, patterns remain faintly visible. Even today, archaeologists find traces of ancient human fields, roads, and canals hidden beneath jungles or deserts, detectable only through satellite imagery. Imagine scaling that kind of subtle engineering back millions of years. The traces could be so faint that they appear to us as nothing more than natural formations. The idea of ancient engineers also forces us to think about intention. Our engineering is often aimed at permanence, buildings meant to last, infrastructure meant to endure. But what if an earlier intelligence sought the opposite? What if they valued impermanence, designing technologies to dissolve, recycle or vanish once they were no longer needed? In that case, we may be looking for something that was never meant to leave a mark. Their success might have been measured not in monuments, but in the absence of ruins, in a seamless integration with the natural world that left little behind for us to find. There is another angle too: scale. Human engineers build at scales that suit our bodies and societies. But what if intelligence in the past worked at larger or smaller scales? Maybe they were microscopic, engineering at the level of molecules and cells. Or maybe they were massive, shaping landscapes as part of their daily existence. In either case, their works would not look familiar to us. They might appear as odd chemical anomalies or unexplained geological formations, things we dismiss as natural because we don't recognize the hand behind them. And what of energy? Our civilization leaves shadows through the ways we generate and use power. We burn fuels, split atoms, harness rivers, capture wind and sunlight. If earlier engineers had their own methods, the traces might still exist. Unusual isotopes from nuclear reactions, rare compounds from chemical industries, layers of soot or ash not tied to natural fires. Even subtle shifts in climate caused by energy use. These would not look like artifacts, but they would be evidence of engineering nonetheless, the ghostly after-effects of technologies long gone. Imagining ancient engineers also means thinking about purpose. Why do civilizations build at all? For us it's survival, comfort, expansion, expression. But what if an earlier intelligence saw the world differently? They might have engineered not to dominate nature but to harmonize with it. Their works might have been gardens, networks of symbiotic species, living systems designed to thrive together. If so, their engineering may not only have vanished but may still exist all around us, woven into ecosystems we assume are natural. Perhaps some of the complexity we see in biology carries echoes of design we cannot perceive, because we expect technology to look mechanical, not organic. And yet, for all the speculation, one fact remains clear. If there were ancient engineers, their traces would be difficult to detect. Time, erosion, tectonics, and recycling would erase most of their works. What we might find instead are shadows, anomalies, whispers of intention hidden in stone or soil. The difficulty is learning how to read them, how to distinguish design from accident, intelligence from geology. Without that, we are left to wonder, to imagine, and to accept that the silence of the record may always outweigh the evidence. Still, imagining ancient engineers is not a futile exercise. It expands our sense of possibility. It forces us to confront how fragile our own engineering really is, how quickly even our most impressive works will vanish. It reminds us that we are not outside of Earth's cycles, but part of them, building briefly before being erased. And it humbles us to think that if others came before, their greatness too may have dissolved into anonymity, their monuments ground down into sand, their cities subducted into molten rock. Perhaps then, the true legacy of engineers is not what they build, but what they inspire. By asking these questions, by imagining what could have been, we remind ourselves that intelligence is not inevitable, permanence is not guaranteed, and memory is not certain. What remains are only the shadows, waiting for us to look closely enough to see them. When you think about memory, whether it's your own or the planet's, there's always a quiet enemy working against it. That enemy is entropy. In physics, entropy is the tendency of systems to drift toward disorder, to move from structure to chaos, from clarity to blur. In daily life, we see it when a tidy room grows messy, when food spoils, when machines break down. In memory, entropy is why we forget. Details fade, edges blur, stories collapse into fragments. And in the history of Earth, entropy is the great dissolver. It's what turns monuments into dust, fossils into fragments, records into silence. Entropy isn't malicious. It's simply the way the universe works. Energy spreads, structures decay, order is always temporary. When you build something, you're fighting entropy, at least for a while. When you tell a story, you're trying to hold a pattern against the pull of forgetting, and when Earth tries to keep its history, it too is working against entropy, though its tools are rock, ice, and chemistry instead of neurons and words. Memory, whether human or planetary, is always fragile because entropy never stops pressing against it. The result is that most of Earth's memory is gone. Entropy has blurred it beyond recognition. Continents grind against one another, folding and melting old rock. Rivers wash layers of history into the sea. Winds carry dust that covers and erodes what lies beneath. Even fossils, which feel permanent to us, are just brief victories against entropy, rare accidents where conditions aligned to hold order for a little longer than usual, but eventually even they will crumble. Entropy waits, and entropy wins. This might sound bleak, but it's also the reason memory is precious. We value fossils, ruins, stories, because they are rare. They are small flames of order flickering in a universe that prefers disorder. Each fossil bone, each shard of pottery, each page of a book is improbable, a little act of defiance against entropy. That improbability makes them matter. They're not just records, they're survivors. For civilizations, entropy is the final challenge. Knowledge, technology, culture, all are fragile. They require constant maintenance, constant rewriting, constant recreation to resist decay. When that work stops, entropy takes over. Libraries burn or rot. Languages die. Buildings crumble. Digital archives fail. Even memory in the brain disappears when the brain itself breaks down. If we vanished as a species, entropy would ensure that our legacy too faded quickly. In a few centuries, our cities would be ruins. In a few millennia, even ruins would be hard to find. In a few million years, almost nothing would remain. Entropy would erase us almost as thoroughly as it has erased those who came before, if indeed they did. And yet, even in the face of entropy, some memories endure. They endure not perfectly, but in fragments, in echoes. That is why Earth still remembers oxygen surging billions of years ago, why it still remembers asteroid impacts in thin layers of iridium, why it still remembers the rise and fall of seas in bands of limestone and shale. These are not complete memories. They're blurry, partial, sometimes misleading, but they are enough to remind us that not everything is lost. Entropy may rule, but memory can persist, however faintly. This balance between entropy and memory is what defines how much of the past we can know. It explains why we see the dinosaurs but not the countless creatures that lived alongside them. It explains why we find a few stone tools but not the full story of early humans. It explains why we know about ice ages but not the details of every ecosystem that came and went. Entropy strips away most of the detail, leaving only outlines. Memory survives as faint sketches where once there were full, vivid pictures. If we imagine civilizations before ours, entropy tells us why their memory would be so hard to find. Even if they were widespread, even if they built and invented as we do, entropy would erase their traces given enough time. A few chemical signals might survive, a few anomalies in rocks or sediments, perhaps a rare artifact buried under unusual conditions, sealed away long enough to avoid decay. But most of it would be gone. The silence we see in the fossil record, the gaps in geology, the absence of clear evidence, all of that is exactly what we'd expect if entropy had been at work for millions of years. There's a strange comfort in this, though. If entropy erases almost everything, then our absence of evidence doesn't necessarily mean absence of presence. It means that memory is fragile, that survival of records is rare. It means we can't be certain, one way or the other, about who or what may have come before. The uncertainty is built into the fabric of the universe. Entropy guarantees that the past will always be mostly hidden, and memory will always be incomplete. But entropy and memory are not just physical forces, they are metaphors for our own lives too. We know that our personal memories fade, that the details of our days blur as time passes. We hold on where we can, through photographs, journals, conversations, but even those eventually fail. Entropy takes them too. That's why memory, when it does last, feels so valuable. It's why we treasure stories passed down generations, why we build archives and museums, why we try to preserve knowledge. We know instinctively that entropy is stronger than memory, so we work all the harder to resist it. And maybe that is the real lesson in imagining Earth's forgotten histories. Even if civilizations rose and fell before us, even if their memories have been erased, the struggle itself, the act of remembering, matters. Our efforts to resist entropy may not last forever, but they give meaning to the time we have. The fossil that survives, the artifact that endures, the story that is told, these are victories, however small, against the universe's drift toward forgetting. So when we think about entropy and memory together, we see both loss and value. We see how little of the past survives, but we also see how precious those survivors are. The thin layers of rock that tell of extinctions, the isotopic shifts that reveal ancient climates, the rare fossils that bring vanished creatures back to life in our imaginations. These are memories that endure just long enough for us to find them, little fragments that entropy failed to erase completely. They are the reason we can even ask whether civilizations came before us, and in that sense, entropy gives memory its meaning. If everything lasted, nothing would be special. If every creature left fossils, if every city survived forever, we wouldn't value them the way we do. It's because entropy erases so much that memory feels miraculous. It's because forgetting is inevitable that remembering feels like a gift. And that truth applies not only to Earth's history, but to our own lives as well. Entropy ensures that the past will always be incomplete, but memory ensures that it is never entirely lost. Somewhere between the two, between forgetting and remembering, lies the story of Earth and the story of us. When people try to make sense of the past, they don't always use fossils, rocks, or isotopes. For most of human history, the tools of memory weren't scientific at all. They were stories. Around fires, in temples, in households, people told tales of how the world began, of floods that washed everything away, of fire from the sky, of golden ages long lost and civilizations destroyed. These myths and stories are not evidence in the way geology is, but they are echoes. They are attempts to remember, to explain, to pass on fragments of something that might once have happened. Every culture has them. In Mesopotamia, the Epic of Gilgamesh tells of a great flood that wiped away nearly all life, with only one man surviving in a boat. In the Hebrew Bible, Noah's flood retells the same theme. In Hindu tradition, Manu escapes a deluge with the help of a divine fish. Across the world in the Americas, indigenous stories speak of floods that reshaped the land and wiped away earlier peoples. Even in Australia, Aboriginal oral traditions preserve tales of sea level rise at the end of the last ice age, describing coasts that were once dry land but are now underwater. Over and over, the theme repeats. There was a world before this one, and it ended. Fire is another recurring theme. Stories of destruction by flame appear in Greek myths of Phaethon losing control of the sun's chariot, in Norse tales of Ragnarok where fire consumes the earth, in Zoroastrian visions of purifying flame. Sometimes the fire comes from the sky, sometimes from within the earth, but always it signals an ending, a reset. Combined with flood myths, these stories weave a pattern of cycles: creation, destruction, renewal. They sound remarkably like the geological rhythms we know from science: ice ages, volcanic eruptions, asteroid impacts, mass extinctions. Myths don't give us data, but they hint at memories carried in culture long after events themselves are gone. And then there are the stories of earlier ages of humanity. Hesiod, the Greek poet, wrote of 5 ages: the Golden Age, the Silver Age, the Bronze Age, the Age of Heroes, and the present Iron Age. Each was more corrupt and fragile than the last, and each ended in ruin. Hindu cosmology speaks of cycles called yugas, vast ages that repeat endlessly, with civilizations rising and falling in predictable succession. In Mesoamerican belief, the gods created several worlds before this one, each destroyed in turn by floods, jaguars, fire, or wind. The Maya described suns that ended and were replaced. Over and over again, the message is that our world is not the first. Others came before. Now, myths are not geology. They are not reliable records of exact events. They are shaped by culture, belief, imagination. But it's striking how often they align with real patterns we see in the Earth. Floods did happen, especially as the last ice age ended and seas rose more than 100 meters. Volcanoes did erupt with devastating power. Asteroids did strike, reshaping ecosystems overnight. Civilizations did collapse, whether through war, famine, drought, or disease. Myths may not tell us exactly what happened, but they may preserve the emotional truth of survival, that people lived through endings and told stories about them. This raises an intriguing possibility. Could myths also preserve faint memories of civilizations so ancient they are otherwise lost? Could stories of golden ages, of worlds before this one, be distant cultural echoes of real events so deep in time that no physical evidence survives? Some researchers are cautious, warning that myths often reflect universal human experiences: floods, fires, loss, renewal, rather than specific historical memories. But others point out that oral traditions can be astonishingly durable. Aboriginal stories in Australia, for example, appear to have preserved accurate accounts of coastlines from over 7,000 years ago, passed down through generations without writing. If stories can survive that long, perhaps some can stretch even further, carrying kernels of truth far beyond what we usually assume. Even if myths are not literal memories, they often carry symbolic parallels to the scientific record. The flood myths resonate with the repeated cycles of sea level rise and fall. The fire myths echo the devastation of volcanic eruptions or even asteroid impacts. The Golden Ages resemble interglacial periods when climates were warm and stable, giving rise to flourishing cultures. The endless cycles of Hindu yugas or Mesoamerican suns reflect the reality that Earth does move in cycles of creation and ruin, though on scales of time far longer than human generations can normally perceive. It's as if myth and geology are speaking in different languages but telling similar stories. There's also the possibility that myths encode memories of human civilizations that really were forgotten. We know that entire cultures have disappeared, leaving behind little or no trace until archaeologists rediscovered them. Göbekli Tepe was buried and unknown for thousands of years until its recent excavation revealed monumental architecture built long before cities were thought to exist. The Indus Valley civilization, with its complex cities and plumbing, was forgotten until the 20th century. The Maya were once thought to be simple farmers until their ruins were uncovered in the jungle. If this happened in the span of a few thousand years, how much more could be lost over tens of thousands? The myths of vanished ages may not be evidence of civilizations millions of years old, but they remind us how easily even recent ones can disappear from memory. Imagining parallels in myth and story also highlights something about ourselves. We too tell stories of worlds before, of civilizations that might come after. Science fiction is full of it. Tales of lost planets, forgotten empires, cycles of rise and fall. In a way, we are continuing the same tradition, creating myths for our own age. Whether ancient or modern, myths serve the same purpose. They give shape to the uncertainty of memory. They preserve patterns of loss and renewal. They remind us that nothing is permanent. So while myths are not proof of forgotten civilizations, they are part of the larger conversation. They show that humans have always sensed the fragility of their worlds, have always suspected that others came before, have always felt the cycles of creation and ruin. They may not tell us who those others were or what exactly happened, but they keep alive the possibility, the intuition, that we are not the first and will not be the last. And that possibility, whether born of geology or story, is enough to keep the imagination turning. It keeps us listening for echoes in both stone and myth, wondering whether the stories we tell today will one day be remembered as faint parallels of truths we cannot yet see. When people wonder about life in the universe, they often point to the stars. There are billions of them in our galaxy alone, many with planets orbiting them. Some of those planets must be like Earth, with liquid water, stable climates, and long spans of time for life to evolve. By the numbers, civilization should be everywhere. Yet when we listen for signals or look for signs, we find nothing. The silence of the sky is as deep as the silence in the fossil record. This puzzle is sometimes called the Fermi paradox, and one of the most sobering explanations for it is the idea of the great filters. The great filters are barriers, challenges so difficult that most life never gets past them. Some filters may come early, stopping life from ever forming in the first place. Others may come later, preventing intelligence from rising or civilizations from lasting. The concept is unsettling because it suggests that the universe is not empty by chance. It is empty because most attempts at civilization fail. If we think about forgotten versions of Earth, the idea of great filters takes on a new meaning. Maybe we are not the first. Maybe others rose before us and met filters they couldn't survive. Their stories ended, their traces erased, and we are left to wonder whether we too will face the same barriers. The filters are not just abstract ideas about the cosmos. There are real possibilities here on this planet, shaping both the past and the future. Some filters might be biological. The leap from simple life to complex multicellular organisms took billions of years on Earth. For most of the planet's history, life was microscopic, single-celled, modest in its complexity. Maybe intelligence is rare because it takes extraordinary luck for life to move beyond that stage. If so, then Earth's story might include countless false starts, living systems that thrived but never made the jump to complexity. If any of them reached intelligence briefly, perhaps they lacked the resilience to spread, and entropy erased them before they could leave lasting marks. Other filters might be environmental. Earth is a restless world, with ice ages, mass extinctions, volcanic eruptions, and asteroid impacts. Each of these could have been a filter, ending possibilities before they fully matured. If civilizations existed millions of years ago, perhaps they faced one of these disasters and couldn't recover. Our own species, for all its resourcefulness, would struggle to survive a collision like the one that ended the dinosaurs. If an earlier intelligence faced such a catastrophe, their story may have ended in a geological instant. Then there are filters that come with intelligence itself. The same creativity that allows a species to build tools and shape its environment also allows it to create dangers it may not survive. Weapons, unchecked resource use, environmental collapse. These are self-made filters. If we're not the first, perhaps others reached this stage and failed. Their technologies became their undoing. Their ambitions outpaced their wisdom. The Earth recycled their traces and only the silence remains. For us, the most pressing question is whether our filters lie behind us or ahead of us. If the great filters are mostly in the past, if the hardest step was the emergence of life or the leap to complexity, then perhaps we are rare and precious, one of the few species to make it this far. But if the great filters lie ahead, if the hardest step is surviving our own intelligence, then our future is precarious. It would mean that civilizations often rise but almost always fall, erased by their own hands or by the indifferent hand of nature. This perspective adds weight to our speculations about forgotten civilizations. If Earth has hosted others before, their disappearance may not have been mysterious at all. It may have been the natural outcome of filters. They rose, flourished for a time, but could not pass through the narrow gates that separate survival from extinction. Their presence was brief, their memory erased, their story another page wiped clean by time. And if that is true, then perhaps we are walking the same path, facing the same filters, with no guarantee we will fare any better. Still, the idea of great filters is not purely grim. It also reminds us of resilience. Each filter that life has passed on Earth is an extraordinary victory. The leap from chemistry to biology, the persistence of single-celled life through billions of years of upheaval, the emergence of multicellular complexity, the survival of mammals after the asteroid impact, the rise of human intelligence against long odds. Each step could have been the end, but it wasn't. The fact that we are here at all means that Earth and life upon it has already passed through countless filters. That resilience gives us perspective. Even if others came before and failed, we still have the chance to learn from the idea. We can recognize the risks of our own technologies. We can acknowledge the fragility of our environment. We can act with the knowledge that survival is not guaranteed but possible. The great filters are not walls we cannot pass. They are challenges we must face consciously, with humility and care. And perhaps this is the greatest parallel between the concept of forgotten civilizations and the idea of filters. Both remind us that permanence is not promised. Both tell us that civilizations can vanish, their traces erased. Both warn us that intelligence does not guarantee survival. But both also remind us that survival, when it happens, is remarkable. It is a story worth telling, worth protecting, worth remembering. If there were others before us, we may never know their names, their works, or their stories. But we can learn from the silence they left behind. We can treat that silence as a warning, a shadow of the filters they could not pass. And in doing so, we might increase our own chances of making it through the barriers that lie ahead. The great filters, in the end, are not just about the cosmos. They are about us, here and now. They are about whether we can recognize the fragility of our place in the world, whether we can face the challenges without succumbing to them, whether we can leave more than silence in the layers of the earth. When we look up at the night sky, we're not just seeing stars, we're looking at time. Every point of light is a messenger from the past, carrying its story across distances so vast that we measure them not in miles but in years of light itself. To look at a star 100 light-years away is to see it as it was 100 years ago. To look at a galaxy 1,000,000 light-years away is to see it as it was when our earliest ancestors were still figuring out fire. The universe is a vast archive of the past, written not in stone or soil but in light. And when you begin to see it that way, the question of whether we're the first version of Earth feels different. It's not just about this planet anymore, it's about whether intelligence and civilizations are part of a larger cosmic pattern. Cosmic perspectives shift the scale of the question. On Earth, we measure time in generations, centuries, maybe millennia if we stretch our imagination. But the cosmos operates on billions of years. Stars are born, live and die in spans that dwarf human history. Galaxies collide and merge over scales longer than life on Earth has even existed. Against this backdrop, our own story is impossibly small. Even if humans survive for millions of years, even if we build civilizations beyond anything we can imagine, we will still be temporary flashes compared to the universe itself. And yet, we're not entirely insignificant. For all the vastness of the cosmos, intelligence has a unique role. It notices, it reflects. It asks questions like the one we're asking now. If other civilizations have ever existed on Earth or elsewhere, what matters is not just their rise and fall, but the fact that they once looked at their world and wondered. To think cosmically is to realize that intelligence, however brief, is a way for the universe to know itself. This perspective also helps explain why evidence of earlier civilizations might be so elusive. Even if the universe is filled with life, the chances of two civilizations existing at the same time and close enough to notice each other may be small. Civilizations may rise and fall quickly compared to cosmic timescales. That's why the sky is silent. And that may also be why Earth feels empty of memory. If there were earlier civilizations here, they may have come and gone in spans too short to leave lasting cosmic signals. Their presence was local, their traces erased before anyone else could notice. But cosmic perspectives don't only highlight our smallness, they also highlight our connections. The elements in our bodies, carbon, oxygen, iron, were forged in stars. The calcium in our bones, the iron in our blood, the oxygen we breathe were all born in cosmic furnaces long before Earth existed. We are, in the most literal sense, made of stardust. That means if civilizations rose on Earth before us, they too were made of the same cosmic material. Their rise and fall would have been part of the same universal process that created us. In that sense, whether or not they existed, we are part of the same unfolding story. Looking at the cosmos also sharpens our sense of rarity. We know of countless planets now, orbiting distant stars. Many are in the so-called habitable zone, where liquid water could exist. And yet we have no evidence that any of them host life, let alone intelligence. That silence makes Earth feel both fragile and extraordinary. It suggests that even if civilizations have existed before us here, they may be vanishingly rare across the cosmos. That doesn't diminish the possibility of earlier Earths. It deepens it, reminding us that this planet is a precious cradle, one where intelligence has managed to appear at least once, and maybe more than once. There's also the humbling thought that even if civilizations rose elsewhere, we might never know. Light travels far, but signals weaken, and entropy eats at them too. If another civilization sent out radio waves millions of years ago, they would now be faint, scattered, indistinguishable from the cosmic background. If they built monuments on their worlds, those monuments would not be visible across galaxies. Cosmic perspective teaches us that even civilizations are ephemeral, their stories hard to share across the abyss. The silence we hear may not be absence, it may simply be distance and time doing their work. From this view, the question of whether we're the first version of Earth is part of a larger question. Are we part of a pattern that repeats across the cosmos, or are we a rare exception? If civilizations rise and fall frequently, then perhaps the universe is filled with forgotten stories, planets that once thrummed with cities and now lie quiet. If we are rare, then perhaps our story is one of extraordinary luck, a unique flare of awareness in a mostly silent universe. Either way, the cosmic view emphasizes how precious the present moment is. It also reshapes our sense of responsibility. If civilizations are rare, then the survival of ours matters not just for us, but for the universe itself. If we are one of the few sparks of intelligence to appear, then preserving that spark is a cosmic duty. Even if civilizations have come before us on Earth, we are the current bearers of that awareness. Our choices, our actions, our survival carry weight beyond our planet. In the silence of the cosmos, every voice matters, and ours may be one of the few. So cosmic perspectives do not give us answers about earlier Earths, but they give us context. They remind us that silence is not surprising. They remind us that forgetting is universal. They remind us that memory, when it survives, is a rare miracle. And they remind us that our questions, our curiosity, are themselves extraordinary fleeting sparks of awareness in a vast and ancient universe. We live surrounded by the sense that our world is solid. Buildings stand tall, roads stretch endlessly, digital networks connect billions, and our technology feels permanent simply because it is everywhere. Yet when you step back, when you measure our age not by decades or centuries but by the scale of geology, you start to see how fragile all of this really is. Our civilization, for all its power and complexity, rests on a foundation that is astonishingly thin. A shift in climate, a collapse in resources, a disruption of ecosystems, or even our own missteps could unravel it far faster than we are comfortable admitting. If earlier civilizations ever existed on Earth, their fragility would explain why we find no clear trace of them now. And when we look honestly at ourselves, we see the same vulnerability reflected back. Our great cities depend on a delicate balance of infrastructure, supply chains, and energy flows. Interrupt that balance for long enough, and even the strongest societies begin to fray. History shows us this repeatedly. The Roman Empire, with its sprawling roads, aqueducts and armies, seemed indestructible at its height. Yet over time, it fragmented, declined, and left ruins that were buried, scavenged, and forgotten. The Maya built monumental cities in the jungle, only to abandon them under the weight of drought and political strain. The Indus Valley civilization, with its intricate plumbing and urban planning, disappeared so thoroughly that it was not rediscovered until the 20th century. All of these were great civilizations by human standards, and yet they proved fragile. Their collapses were not always sudden but gradual, as pressures mounted until the systems could no longer hold. Now imagine scaling that fragility to the geological timescales we've been considering. If our entire industrial civilization were to collapse tomorrow, what would remain of it in 10,000 years? In 1 million? In 100 million? The answer is sobering. Very little. Concrete crumbles, steel rusts, plastics fragment, data vanishes with the servers that store it. Our fragility is not just political or economic, it is physical, woven into the very materials we build with. Even our attempts at permanence are fragile. Nuclear waste storage is designed to last for tens of thousands of years, yet earthquakes, erosion, and human error make such guarantees uncertain. Digital archives feel endless, but depend on machines that need constant power and maintenance. Paper can burn, hard drives fail, stone erodes. Every medium of memory is temporary. This means that unless we are actively maintaining and renewing our civilization, entropy will strip it away. Our age will not be remembered for its strength, but for its vulnerability, for how quickly its apparent permanence could dissolve. And fragility does not come only from the outside, it comes from within us too. Our dependence on growth, on consumption, on increasingly complex systems makes us less resilient in some ways, not more. A small failure in one part of the system can cascade outward, disrupting food supplies, economies, even stability itself. In the past, smaller societies could collapse locally without shaking the entire world. Today, we are so interconnected that a disruption in one place ripples globally. Our fragility is amplified by our reach. At the same time, our awareness of this fragility is part of what makes us different. We can see it. We can name it. we can compare ourselves to the ruins of those who came before and recognise that we are not exempt. That awareness gives us a chance to act differently, to build resilience where we can. But it doesn't change the underlying truth. Our age, like every age before it, is temporary. If we vanished, Earth would not preserve us in full detail. We would leave behind shadows, traces and chemical signatures, but most of our story would vanish into the same silence that has swallowed so many before. There's a humility in recognising fragility. It strips away the illusion of permanence and leaves us with something more honest. We are not guaranteed a future. We are not immune to collapse. We are not so different from the civilizations that thought they would last forever, only to be undone by pressures they underestimated. Fragility is not an exception, it is the rule. And yet fragility is not the end of the story. It is also what makes us precious. Because our age is fragile, it is worth protecting. Because it can vanish, it matters that we care for it now. Fragility means impermanence, but it also means urgency. The choices we make, the way we treat our planet, the way we prepare for risks, these matter precisely because our civilization is not indestructible. In knowing how easily it can be erased, we are reminded how valuable it really is. So when we wonder about forgotten civilizations, the fragility of our own age gives us perspective. It shows us that if they did exist, their disappearance was not surprising. It was inevitable. And it shows us that our own survival depends not on pretending to be invincible, but on embracing our fragility, adapting to it, and finding ways to endure in spite of it. When you look at the history of Earth, it's easy to focus on the endings: extinctions, collapses, ruins, silences. But alongside all of that loss is another pattern, one just as constant, the pattern of renewal. Earth does not only erase, it also begins again. Oceans dry and reform, climates swing back and forth, forests regrow, species radiate after extinctions, and life finds new ways forward. These cycles can be harsh, but they also carry a strange comfort. They remind us that even though everything is temporary, nothing is final. The story continues over and over in endless variations. Forgetting this is easy, because from the human perspective, endings feel absolute. When a city falls, it feels like the end of the world. When a culture collapses, it feels like history itself has broken. But in the larger cycles of Earth, these are not endings so much as transitions. Rome fell, but Europe did not end. The Maya cities were abandoned, but people lived on. Even mass extinctions, devastating as they are, make way for new bursts of diversity. The dinosaurs were erased, but mammals flourished in their absence. Each collapse carries within it the seed of renewal. This rhythm is not limited to geology or biology. It runs through our stories and our cultures too. Myths of floods and fires almost always include renewal afterward. Gods recreate the world. Survivors rebuild. Golden ages give way to darker times, but the cycle continues. In Hindu cosmology, the yugas end in collapse but begin again in rebirth. In Norse mythology, Ragnarok destroys the gods, but new ones rise. Even in our modern thinking, we sense this. We talk about cycles of history, about rises and falls, about pendulums that swing back and forth. The comfort in cycles is that nothing is ever the final word. If earlier civilizations existed on Earth, their disappearance fits into this same rhythm. They may have risen, flourished, and fallen, but their fall did not mean the end of life or the end of possibility. It meant transition. The Earth recycled, renewed, and allowed new forms of intelligence to emerge later, just as it allowed us. This doesn't erase the sadness of what was lost, but it softens it with the knowledge that the story carried on. The silence is not just an absence, it is also a space in which something new could grow. For us, this idea is both humbling and reassuring. We know our civilization is fragile, and we know it may not last forever. But cycles remind us that even if we collapse, Earth will not be done. Life will continue, new forms will rise, The planet will heal from whatever scars we leave. From the perspective of geology, our age is a chapter, not the whole book. That doesn't mean we should give up or stop caring. It means that we can act with the understanding that we are part of something larger, a cycle that will continue whether we succeed or fail. Cycles also teach resilience. When you know that endings are not permanent, you can face them differently. Civilizations that collapse may not vanish completely. Their knowledge, their traditions, their influence can survive in fragments, carried forward into the next cycle. We are the inheritors of countless forgotten cultures, carrying echoes of their language, their stories, their discoveries. Even if we don't know their names, they are part of us. In that sense, no cycle is truly erased. It is transformed. And there is comfort in knowing that our own contributions may live on in ways we cannot predict. The technologies we create, the changes we make to the planet, the stories we tell, fragments of these will filter into the future even after we are gone. They may inspire new forms of life, new ways of thinking, or simply leave subtle marks that remind the Earth of our presence. We may not be permanent, but we are not nothing. The cycle will carry traces of us forward. The comfort in cycles also comes from perspective. If you see history as a straight line that ends in collapse, the future feels bleak. But if you see it as a cycle, collapse is not final. It is part of the rhythm. That doesn't make it easy or painless, but it does make it survivable. It means that endings are always followed by beginnings, even if we are not here to see them. That thought can make the fragility of our age easier to bear. It reminds us that impermanence is not failure. It is the way of the world. So when we look for earlier civilizations and find only silence, perhaps we should not only mourn what may have been lost, perhaps we should also see the possibility that their endings made space for us, just as our ending someday will make space for whatever comes next. That is the comfort in cycles. We are part of a pattern that has no final word, only chapters, only variations, only the endless renewal of Earth. From the very first thought of whether we might not be the first version of Earth, to all the paths we've followed through fossils, sediments, myths, and even the stars, this has been a journey of perspective as much as possibility. We've wandered through silence, through cycles, through shadows, through the memory of air and ocean, through the fragile remains of what might have been. And now we've arrived here, together, in the quiet of a reflection. The truth is, we don't know. We may never know. Maybe we are the first, the only civilization Earth has nurtured to this point. Maybe we are one of many, with others long erased by time, entropy, and the recycling of the planet itself. Both possibilities are extraordinary. If we are the first, then we are living something unprecedented in 4.5 billion years of history, a kind of miracle of chance and survival. If we are not the first, then we are part of a lineage that has repeated itself across time, part of a cycle bigger than we can yet see. Either way, the weight of the question is enough to make us pause, and in that pause, there is a reminder. Whether or not others came before us, we are here now. We are the current caretakers of this fragile age, the present version of Earth's experiment with intelligence. Our choices matter. Our stories matter. Our memory matters. If the Earth holds only fragments of what came before, perhaps we can try to leave clearer traces for whatever might come after, not just in stone or chemistry, but in how we live, in how we preserve knowledge, in how we treat the world that sustains us. The reflection also circles back to fragility. We've seen how civilizations vanish, how fossils are rare, how geology erases, how entropy waits. But fragility doesn't mean futility. Fragility means urgency. It means that what we do today matters more, not less. It means that our kindness, our curiosity, our creativity, and our care are not wasted even if they vanish someday. They matter because they are real now in this moment, in this brief spark of awareness that we share. And perhaps that is the greatest comfort of all. We don't need certainty about the past to value the present. We don't need proof of forgotten civilizations to recognize that our own civilization is worth protecting. We don't need to know whether we are the first or the 100th to understand that what we have is precious, fleeting, and full of meaning. The cycles will continue, the planet will recycle, entropy will work its erasures, but here, in this small span of time, we get to notice, to wonder, to reflect. That is our role, that is our gift. So as we close, take a breath and think about where you are. Maybe you're listening in the quiet of your room, or on a late walk, or drifting towards sleep. Wherever you are part of this story, part of this fragile age, part of this moment of reflection. And maybe that's enough. Maybe the best way to honour the mysteries of the past and the uncertainties of the future is simply to be present now, to live fully in the cycle we are in, to treat our world and each other with care. If others came before us, we carry their echoes. If others will come after us, we will become echoes for them. In between, we are here, in the flow of time, in the comfort of cycles, in the fragile, extraordinary present. And that, more than anything, is worth remembering.